Hi everybody, so today we're going to solve the code trails for architecture, which is for ECOM web app, trying to scale it for the high peak loads for Black Friday. So I'm going to start a session on my already prepared code trail. And the code trail is on the ECOM platform, which is absolutely okay-ish architecture, but it needs to be also scalable for high peak loads, such as the Black Friday. So we'll start coding, and I'll show you the existing architecture. So we have the client layer with the web application, mobile application, as well as we have the application layer with the web server, which is a single web server, which then works with different services, starting from the product service, inventory, order, payment, notification, and user service, which basically have been called synchronously. Then each of the service also works with the file storage, as well as the Postgres database, which is a single instance. And this database basically serves all of the services. And there are also external services like payment gateway, which works with the payment service, email with notification, and SMS with notification. So this is pretty much the architecture. Now let's try to convert it into more resilient, high load, capable, and scalable. So what I noticed immediately is we have just one instance of a web server. So let's try scale it, and let's add multiple instances and the round robin to basically do the balancing. Multiple instances. Okay, so we're adding that, and I think next what I'll do, I will scale the database. We'll make it a cluster. Right now it's a single database. It's a single Postgres database. Okay, so let's take a look. So we have now web server 1, web server 2, and web server 3, and let's make it clear what we've added. So this is our diagram now. So we now have the balancing layer, which is Nginx, and we have web server 1, web server 2, and web server 3. And basically each of these web servers works with the respective services in our application layer. So this is nice. Now let's fix the database, which is still a single instance. So what we want is to make to be a cluster. That will help reduce the failure side on the database. And after we're going to do that, we will also, I think, have to introduce the cache and CDN for the file and product images. So this is important. This is ECOM. So okay, so here we are. So we have now a database cluster, which is the primary DB and 2 replicas, and the services now work with this cluster. Okay, so let's now add cache and CDN for the product images. So let's add cache for images in file storage and cache for the database to reduce reads. So let's do that. And I think the next big thing would be for us is to also take a look at the sync calls between the services. So we need to make them async. But let's work through the cache first. Okay, so now we have Redis cache and we have CDN. So now both of our mobile application and web application, they work with the respective cache with the CDN, which then works with the load balancer and the file storage. Okay, so this is nice. Let me see, what else do we have? So we also have here Redis cache, and it works with the cluster and the services to reduce the load on reads. Okay, so we have this one done. Let's now take care of these direct calls on the server side. So every service, when it calls to the other service, this has to be async because there could be significant wait time on some of those, and we do not want to break the whole chain of command when we're doing this. So let's add async. Now let's formulate it in a bit different way. So we want to do let's introduce event-driven architecture for the service calls. Architecture for the service calls. Okay, so we now have the message queue layer, which has the broker, which has order queue, inventory queue, payment queue, and notification queue. And every service works now through the subscription model. So basically, we have ability to unlock in async way the work of the services. This is really good. So this adds way more resiliency. And the notification service is now doing the async calls for the external services, which is absolutely the right thing to do, not to break things. Okay. So I think let's just recap quickly what we did so far. So on our state of the things, we did a couple of things here. So we basically introduced the caching layer. So the web application, mobile application stays the same. Then we introduced the caching layer. So now we work through the CDN, which works with basically respective file storage for the images, and it works with the load balancer. And that load balancer works with the API gateway that then works with the web server 1, 2, 3. And each of the web servers work with the respective product services, order services, and other services, which works in async way, which basically works with the database cluster now, not a single database. Also uses the cache for reads, as well as we have all of the kind of operations now going through the message broker in async way. So inter-service communication is now going through the message queues. Okay, so I think this is a good one. Let's also add some telemetry. Okay, so let's add. So telemetry is important. And I think we also need to scale the services themselves. So currently each service is just one instance. And I think we need to have at least 2 each to be able to load balance them and also be more resilient if one of them fails. So let's add the telemetry and then let's work on the services instances. Awesome. So let's compare to take a look what we've added. So we've added quite a lot of things. And this is basically the distributed tracing. And now we have the log aggregator and the metrics collector. So we have added the whole observability layer now, and we plugged it into all of our services to be able, and database, and basically on everything that we have to collect traces and collect the telemetry data on the work of the application, which is really, really handy. Now let's do the final thing, which I think is very important, is scale our inventory and other services into multiple instances. So let's scale the services to for resiliency. Awesome. So let's take a look. So now we have added a lot in terms of the new things to the architecture diagram, but basically because they are concerning the core of the thing, which is the services. So now we have the permit service, which has like 3 instances, and we have notifications 3 instances. So we have like, I think 3 instances of each service, which help us maintain the resiliency on the level needed. So I'm going to turn off the compare and just flip to the diagram itself. So now this is how the more resilient and more capable architecture of ECOM looks like, which is, you can see a lot of the differences. So we had a lot of single instances of everything. Now we have added ability to do the load balancing, the cache for the CDN, for the images, and for the database. We added a database cluster. We've added telemetry. We've scaled our services. We've added event-driven architecture for the inter-services communication. So this really helps us to serve the load better and be able to withstand massive load of the system. And if I go to the initial state, this is how the initial state looked like. So we had just the clients, and then we had the single instance of the web server, then the single instances of each services, and all of the communication was synchronized, and there was a single instance of the database. So on the event of the order coming through, we would synchronously process it, and if one of the services would take a longer time to process, let's say inventory service, and there would be a fail, we would have to retry. But the whole chain would really be so long that most likely we would just have a pushback as the timeout request. So if you go to the current code, this is a way more robust architecture. So it all starts from kind of the request, which comes from, again, those 2 clients, but then it goes to the CDN, or it goes to the so let's just go step by step how it follows. So we have web application or mobile application, which works with CDN. Then CDN basically works with the file storage for images. This is for CDN. Or it works also with the load balancer, which is Nginx. Then the Nginx works with the API gateway. And the API gateway is serving us 3 web servers. So there's web server number 1, number 2, and web server number 3. It also stores the telemetry data into the observability framework. So now each of the servers is also talking to the order service, all of the kind of the services that we have, which are also scaled on the 3 instances each. And each request is going through the load balancer. Now each of the service also works with the respective Redis cache to read the data from cache. And it also works with the basically telemetry to store the data, with the cluster database. And it also works with the other services through the event-driven architecture. So here you see that we have the kind of a subscription model. And let's say if you take a look at the inventory queue, then we'll see that the services works through the queue itself. They're not working directly. So let's say inventory and the payment, they're working together through the queue. So this is how the overall architecture looks like. And I'll just take a look at the database cluster as well. So we have added a cluster with, I think, 2 replicas, okay? And they work now with the whole system. So that's basically how the architecture looks right now. And once we submit it for the review, we're going to be able to receive a feedback on it. So let's do that. Okay, so we completed session successfully. We've got 85 out of 100, which is not too bad. And there are a couple of growth opportunities that we could also take a look at and just try to implement to progress our architecture even better, like working with the APIs and health checks and doing this database sharding strategy and adding circuit breakers and stuff. So this is all kind of a good points to kind of go ahead and improve even further. And from the criteria breakdown, I think we've basically scored pretty high on everything except the fault tolerance. And the fault tolerance is about the observability layer, which Okay, so it's also, yeah, so it's obviously we could go deeper and build additional mechanisms for secret breakers, bulkheads, same configuration, exclusive fallback strategies. So this thing is really interesting, and it basically tells me that we could also go with this architecture into more kind of a Saga pattern when we're going to be like adding the Saga orchestrator, which would work with different scenarios and would assure us the eventual consistency of the whole kind of set of operation across the web order. And I think this is a good thing to try in another diagramming trail. And yeah, if you take a look at the diagram, so you're going to see that on the step one, we had pretty simple, like all synchronous architecture of our web application. And at the end, we built quite sophisticated, capable to withstand different like situations architecture, which has all of the different pieces. I'll just turn it off and just show you how it looks at the final state. But yeah, this is pretty sophisticated. It has added a lot of new things to withstand the high load, including CDN, including the Redis cache, including the API and Nginx and API gateway, and scaling of the web service into the cluster, scaling of the services into the multiple instances, adding clusters to the database, adding observability framework. So it's quite a lot of work being done here to transform this synchronous, basically, kind of a single vertical architecture into this horizontally scalable architecture of the ECOM app. And as I said, based on the recommendations, I think we could also do here the Saga pattern to really kind of build eventual consistency, which is still lacking here. But yeah, for this exercise, I think this is done. So I hope you enjoyed this one and hope to talk to you soon. Bye-bye.